All right. This is number 3. Essay number 3. Okay. So we're going to be talking about the sympathetic division of the autonomic nervous system and the parasympathetic division of the autonomic nervous system. So first we got the nervous system. We got central nervous system and peripheral. In the central nervous system, we got brain, spinal cord. In the peripheral nervous system, we got, first we got spinal nerves and cranial nerves. We've also got somatic nervous system. And then autonomic nervous system. So with the somatic nervous system, you got motor and sensory. And the autonomic has sympathetic nervous system and parasympathetic. Nervous system. So the sympathetic nervous system is fight or flight. As well as it's also called the craniothoracic and parasympathetic is rest, digest, which is the cranial sacral. So, that's a little bit about the nervous system. So some of the differences between these two. So the somatic nervous system is for like muscles. And I guess we can talk about each. So, the sympathetic nervous system is T1 to L2. Pretty sure. And then it has preganglionic, and postganglionic neurons. And all of these ganglia are, you've got the sympathetic, let's see, I guess we'll do chain ganglia, which is near spinal cord. So, in these preganglionic neurons, you've got acetylcholine, which is ACH, and then your postganglionic neurons release something called epinephrine or norepinephrine. Except, so there's like a little exception over here. For the sweat glands, only so the sweat glands release acetylcholine in the postganglionic neurons and preganglionic neurons. There are two types of receptors. We can write those down here. That is, let me make sure I spell them right. Cholinergic receptors and adrenergic receptors. Okay, so on the postganglionic neurons, you have a cholinergic receptor. We're going to do this in blue highlighter. So it was a little bigger than I was wanting. So that is a nicotinic receptor, which we'll just put as N2. And then the postganglionic neurons have alpha and beta adrenergic receptors. Okay, like I said, sympathetic is fight or flight. Okay, now we can jump over to parasympathetic. We're gonna put this exception a lot smaller over here. Okay. All right. Now we got the parasympathetic nervous system. This is the rest and digest. It's also called the craniosacral. So this has the cranial nerves, three. Oh, sorry. That is my family group chat. So, cranial nerves 3, 7, 9, and 10. And you've also got the sacral spinal cord. S2 through 4. So cranial nerve 10 is the vagus nerve. That does about 80% of all of the innervations. It does a lot of the work. So just like the sympathetic nervous system, there are preganglionic and postganglionic neurons. So we can just go like this. Make it a little smaller here. Okay, but the difference here is that there is acetylcholine on both the preganglionic neurons and postganglionic neurons. The location of the ganglia is close to the target organs. So an example of that would be, let's see, I can show you my other notes here. Oh, right here. This picture is really good. I like it. So an example would be the collateral ganglia, sympathetic, well, actually not the sympathetic nerves. Splanchnic nerves, so those go to like the liver, stomach, duodenum, large intestine, small intestine, kidney, and then these collateral ganglia also are associated with the parasympathetic nervous system. And then you also have this adrenal gland, but I am going to talk about that a little later. But yes, so you got the vagus nerve, and then sacral division, S2 through 4. And actually, with the sympathetic nervous system, I was talking the collateral ganglia and the splanchnic nerves and the adrenal gland are all with the sympathetic nervous system. I thought I was still talking about the sympathetic nervous system for a second. But the parasympathetic nervous system is different than that. So, back to our normal diagram over here. So we've got nicotinic receptors on the postganglionic neurons, just right here, just where it is. And then you've also got muscarinic receptors over here. So I can't remember how many there are, but those are the muscarinic receptors. And then, so the parasympathetic nervous system decreases heart rate, also constricts pupils, and increases digestion. And I forgot to talk more about the sympathetic nervous system. So with the sympathetic nervous system, it increases heart rate and sweat. And it will dilate pupils and bronchioles. So this is kind of what gets things like adrenaline pumping, is the fight or flight. So that'll increase your heart rate. But the rest and digest is kind of like calming things down, like bringing down the heart rate. And then you've got the somatic nervous system, which is originates from the spinal cord and the brain stem. So these ones are a little different. They don't have any ganglia. They just go straight to the muscle. Let's say that this is a muscle. And it also, so motor and sensory. So there are neurotransmitters, but the neurotransmitters are releasing acetylcholine is released. Yeah, like I said, it's one neuron. So this one just has nicotinic receptors on the skeletal muscle. So we'll put N2 here. And this controls muscle movement. And this is voluntary. The other ones are non-voluntary. Okay. So, onto these. The cholinergic receptors. You've got nicotinic receptors. And you also have muscarinic. And with these, odd is excitatory. Even is inhibitory. Okay. So the nicotinic receptors, kind of like I showed, are on the postganglionic neuron. And they're also, so they're with sympathetic, parasympathetic, and skeletal muscle. And they have a ligand-gated ion channel, which allows a lot of sodium to come in and potassium to come out, which leads to depolarization to action potential. So the nicotinic receptors, N2, allows the action potential to happen. The muscarinic receptors, these are with the parasympathetic nervous system, and these are G protein coupled receptors. So M1, 3, and 5 stimulate contraction. So 1, 3, and 5 are excitatory. And M2 and M4 inhibitory. Okay, let's bring this down a little bit. these adrenergic receptors, you've got alpha 1, alpha 2, beta 1, beta 2, and beta 3. And like I said over here, odd is excitatory and even is inhibitory. So the location with these does matter though. So alpha 1 is heart. And it increases the heart rate. Alpha actually, let me check to make sure that alpha 1 is the heart. I'm pretty sure. Oh, actually, beta 1 is the heart. Alpha 1 is the blood vessels. So, alpha 1 is blood vessels. Beta 1, heart. Let's see. Beta 2 is the lungs. Beta 3 okay, yeah. Let me make sure I have this right here. Oh, okay. Alpha 1 is also dilating the pupils. Yes. So, the constrictor is M odd, and then the dilator is alpha 1. So, odd is excitatory, so it excites the... Wait. Sorry, I am just a little mixed up here. Okay, yeah. So, if the parasympathetic is excited, then it will cause constriction. But also if the sympathetic nervous system is excited in alpha 1, then the pupils will dilate. Okay. So, let me make sure I got everything here. Oh, okay. So for sympathetic, let's go over some more things. You've got through the spinal nerve, so that kind of like we talked earlier, that could be either like goosebumps, it could be muscle constriction, and it also could be sweat glands. So, but with sweat glands, remember it's acetylcholine twice in the preganglionic and postganglionic neurons. Then you also have the adrenal medulla. So let's pretend we've got, oh boy, that's not going to do. Okay. So we got this. And then we've got our sympathetic chain ganglia. It goes through all the way, keeps on going. And let's say it stops at the adrenal medulla. So that is on top of the kidneys, and it will go through the collateral ganglia, and it synapses at the adrenal medulla and releases acetylcholine. And then in the adrenal glands, there is an N2 receptor that will eventually release. Well, the N2 receptor will receive this, and then that will release epi or adrenaline. And then you've also got, with the thoracic cavity, you've got the sympathetic nerves. So let's just go up here with this. We're going to pretend that we have this here. So we're going from the lateral horn through the ventral root. And then we go to the sympathetic chain ganglia and synapse. And then releases acetylcholine. There's an N2 receptor. And then this postganglionic neuron continues on and then synapses. This is now called a sympathetic nerve. So this goes to the thoracic cavity. So the heart or the lungs. And remember, the lungs is beta 2 and the heart is beta 1. Pretty sure. Yes. Alpha 1 is blood vessels, so it'll constrict. And then yes. Oh, right here, epi is released. Okay. And then you have the abdominal cavity. So with the abdominal cavity, you go like this. So here is the sympathetic chain ganglia. Come out from the lateral horn, through the ventral horn, through the ventral root. Then you go to the sympathetic chain ganglia, but you do not synapse. You keep on going to what's called the collateral ganglia. Then you synapse there. So the collateral ganglia, anything that goes past the collateral ganglia is a splenic nerve. So splenic nerves go to the liver, the stomach, the duodenum. Let's see what else is in there. Liver, stomach, duodenum, kidneys. Anything below the thoracic cavity, pretty much. So here, acetylcholine is released. And then you have another postganglionic neuron. Oh. And that releases epi. So, kind of like I talked about earlier, odd excites and the evens inhibit. And that is pretty much it for the sympathetic nervous system. There's an acronym for the parasympathetic nervous system, SLUD. So, saliva, lacrimation, which is tears, urination, and defecation. All right. So with the parasympathetic nervous system, they are all just coming out of the spinal cord through those different pathways that you got. The cranial nerve 3, cranial nerve 7, cranial nerve 9, and cranial nerve 10, which is the vagus nerve. So with the parasympathetic, that's when you have the what are they called? Muscarinic receptors. So the M's. And for both the preganglionic and postganglionic neurons, they release acetylcholine. So the let's see. And I think that's it. I'm going to read through the prompt again just to make sure. yeah, so pretty much the thing to remember is that odd is excitatory and even is inhibitory. That's it. Thanks for watching.